Hi. Remember the definite integral? It's written as the integral from a to b f of x dx. Here, a is one endpoint and b is the other endpoint, and f is the function. And the definite integral can be interpreted as the area under this curve. And we write that in terms of what's called a Riemann sum. The Riemann sum is the sum of some very thinly sliced intervals, kind of like slicing up a loaf of bread. And so if we consider one interval here, the endpoint is xi, and the width is delta x. The height is f of xi, and so the area of that little rectangle is going to be f of xi times delta x, the height times the width. And so we're going to add up the areas of each of these little intervals that are rectangles. And then when we add them up, we're going to take the limit as n goes to infinity. And so we're going to do a better and better approximation until we get the area as the intervals get smaller and smaller. And so we'd like to have an idea of what these interval sizes are. So delta x would be b minus a over n, which is given right here. And if we want to get to the point xi here, we'd start at a, and then we'd add on I times delta x. And that's what this says right here. Okay, so let's apply this now. And so let's evaluate the definite integral from minus 2 to 5, 6 minus 2x dx. This is our function, f of x right here. And so we know that this is going to be equal to the limit as n goes to infinity of the summation I going from 1 to n, f of xi, so it'll be 6 minus 2 times xi times delta x. Okay, so now we need to figure out what delta x is and what xi is. So if b is one endpoint, this is going to be 5, and a is the other endpoint, it's going to be minus 2. And so delta x, in our case, is going to be 5 minus 2 over n, which is 7 over n. xi will be equal to minus 2 plus I times delta x, which is 7 over n. And so we can plug this in here if we want to. This is the limit as n goes to infinity of the summation I going from 1 to n, 6 minus 2 times minus 2 plus 7i over n times delta x, which is 7 over n. Okay, so that's our formula. We'd actually like to compute the formula exactly, so let's continue through, and we can rewrite this now as being the limit as n goes to infinity, the summation I going from 1 to n. And now we see we have 6 plus 4 will be 10, and then we have minus 14 times I over n times 7 over n. And so we can multiply through by the 7 over n and write that as the summation I going from 1 to n, and that'll be 70 over n minus 98 I over n squared. And now we can separate this out as two sums and write it as the limit as n goes to infinity of the summation I going from 1 to n of 70 over n minus the summation I going from 1 to n, 98i over n squared. So at this point we can see that 70 over n doesn't depend on I, neither does 98 over n squared. So we can pull these constants out. And so we have that this is equal to the limit as n goes to infinity, 70 over n, summation I going from 1 to n of 1, minus 98 over n squared summation I going from 1 to n of I. So we'd like to work out what these sums are, and we can look back to a previous video for the answers. And I'll just write them over here. The summation I going from 1 to n, 1, is just 1 plus 1 plus 1 plus 1 plus 1 n times, and so that's equal to n. The summation I going from 1 to n. I would be 1 plus 2 plus 3 all the way up to n, and it turns out that the answer is n times n plus 1 over 2. And so let's put those in here and here, and so we're going to have that this is equal to the limit as n goes to infinity, 70 over n. And now, instead of summing 1 n times, I'll just put in n, and then we're going to have minus 98 over n squared. And instead of summing I going from 1 to n of I, I'm going to put in the n times n plus 1 over 2. Okay, and you can see there's some cancellations here. So we have a cancellation there, and one of the n's here will cancel with one of the n's down there. And so we can rewrite this as the limit as n goes to infinity of 70 minus 49 times n plus 1 over n. And so we can then take the limit inside, and that's 70 minus 49 times the limit as n goes to infinity of n plus 1 over n. And we can write that as 70 minus 49 times the limit as n goes to infinity. And now we're going to just divide the top and bottom by the highest power of n in the bottom, and that'll be n over n plus 1 over n divided by n over n. So these are ones, and so this is going to be equal to 70 minus 49. And so this is going to be equal to 21. And so that's our answer. The integral from minus 2 to 5 of 6 minus 2x dx is equal to 21.